All right, welcome to day 2 of partial fraction decomposition, the other two cases. All right, here we go. Case 3 is when you have an irreducible quadratic factor. So like you have a quadratic term in your denominator and it won't reduce. Like you can't factor it anymore. You're just kind of stuck with it. And what we're going to do in this case is instead of putting just an a in the numerator or a b, we're going to put an ax plus b or a cx plus d, depending on how many there are. Okay, so let me show you one example real quick. At least I hope it's real quick. All right, find the partial fraction decomposition of this term right here, that fraction. Just like yesterday, we're going to factor the denominator first. So I'm going to take out an x, and that will leave x squared plus 4. Now here's what we're talking about. That x squared plus 4 is not a difference of squares, it's a sum of squares, so it's a quadratic, and I'm stuck with it. Okay, so just like yesterday, here's my numerator. My original fraction is right here. And I'm going to put an a over the x because it's a linear factor. And what I'm going to do for the quadratics, I'm going to put bx plus c. That's the new thing today. Okay, if you have a quadratic that you can't reduce, you got to put a bx plus c, ax plus b, wherever you are in the alphabet. Okay, so I'm going to multiply by the LCD like I did yesterday. I have 2x squared minus x minus 4. I'm going to multiply the a times the x squared plus 4, and I'm multiplying the bx plus c times the x. And let's see what I get. Over here, obviously on the left-hand side, still 2x squared minus x minus 4. The right-hand side, I get ax squared plus 4a plus bx squared plus cx. Now I'm ready to group things like we did yesterday. So left-hand side never changes. Right-hand side, there's an x squared, there's an x squared. So if I pull out an x squared, my coefficient would be a plus b. There's the x, I just have a cx, and I've got a 4a. So I'm going to put an x. The good news is, because I have a 4a there, that's the constant term, and the constant term over there is negative 4. 4a must equal negative 4, so I already know that a is negative 1. Also, the cx, notice the coefficient over there is just negative 1x, so cx must equal negative 1, which means c, I don't know where I wrote x in there, c must equal the negative 1 because that's the coefficient on the x. So I know a and c already. And b, because a plus b has to equal the 2, I'm going to say a plus b equals 2. I know a is negative 1 plus b is 2, which means b is 3. So there's my b, there's my c, there's my a. I'm just going to plug them back up here in the original, just like we were doing yesterday. And my final answer is going to be negative 1 over x plus negative x plus 3 over x squared plus 4. And I promise you, if you added those together, you get right back where we started. We just decomposed that fraction into two different fractions. That was amazing. All right, case 4, the last case, finally. The denominator has a repeated irreducible quadratic factor. So this time we have the quadratic factor like we did a minute ago, except now that factor is also squared or cubed or it's raised to a power. Okay, so that's going to create a whole nother issue. I'm going to show you one, and believe me, it's going to be enough. Okay, this one says find the partial fraction decomposition of this monster here. Now, one thing I want to show you about this problem is that this is the first one we've seen where the numerator degree is larger than the denominator. And when that happens, you're not going to like this, but when that happens, you're going to have to divide using long division first to break it down. We can't, there's just going to be no way to do that otherwise. I would show it to you, but it would be so terrible. So I'm going to divide x cubed plus 2x squared minus x minus 2 into my numerator. 2x to the 4th plus 4x cubed minus 2x squared plus x plus 7. And it's going to go 2x times, multiply everything outside by 2x, and then you get 2x to the 4th plus 4x cubed minus 2x squared minus 4x. And I'm going to go through and do my subtraction there. And when I do that, that's gone and that's gone and that's gone. So it just leaves me 5x plus 7. And x cubed will not go into 5x plus 7. So what I'm left with here is I'm going to do the partial fraction decomposition of my remainder over my divisor. So here's what I have. Probably easier to show you than I'm just sitting here talking about it. What I have now is I have this. I have 2x plus 5x plus 7 over the x cubed plus 2x squared minus x minus 2. All right, so what I'm going to do is I'm just going to do the partial fraction decomposition of this. Okay, so factor the denominator, take out the x squared, that leaves x plus 2, take out the minus 1, that also leaves x plus 2. So we end up with an x plus 1, x minus 1, and an x plus 2. And I'm just going to set that up over here. So don't forget, I still have that 2x. Don't forget the 2x. Okay, so I have 2x plus 5x plus 7 over the x cubed plus 2x squared minus x minus 2. So I can give it an a over x plus 1, the b over the x minus 1, and the c over the x plus 2. And I'm really only worried about this right here for right now. That's all I'm trying to solve here. So I get the 5x plus 7 equals a times the x minus 1 times x plus 2. The b times the x plus 1, x plus 2. And the c times the x squared minus 1. All right, let's simplify this some more. I'm trying to make this smaller, move it up for us. All right, so the 5x plus 7, I still got that 2x though, don't forget it. 5x plus 7, and here I'm going to have ax squared minus ax minus 2a. Same thing with the b. I have bx squared plus 3bx plus 2b. And I'm going to have a cx squared minus c. All right, so if I pull out the x squared, that's going to leave me with an a plus b plus c. Those are just the x squareds in that problem. Let me change colors here. Let's get the x's now. There's an x, there's an x. That's all the x's. So if I pull out the x, that leaves me a negative a and a plus c. Nope, sorry about that, plus 3b. Losing my colors here. And one more, let's do the constants. There's a constant, there's a constant, there's a constant. So if I group the constants together, I get negative 2a plus 2b minus c. Still, this is the same thing we were doing yesterday. It just started off a little bit tougher. All right, so here's where I get to. My system is going to be a plus b plus c has to equal 0 because there's no x squared over here. Negative a plus 3b is going to equal 5 because that's the coefficient on the x over there. And negative 2a plus 2b minus c is going to equal 7 because that's the constant term over there. Now, to save time on the video, I'm going to go ahead and just solve this real quick, just tell you the answer. The a term should be 2. When you solve it, the b is going to be negative 1, and the c is also going to be negative 1. Now, I did that in a hurry, just I want to show you how you're going to write your answer here. Remember, I keep saying through this whole problem, don't forget the 2x. The 2x is still there because we divided, so my answer is 2x plus. Then I'm going to start the 2 over x plus 1, the negative 1 over the x minus 1, and the negative 1 over the x plus 2. And that's your final answer right there. All right. And like always, I say this at the end of almost every video, but we'll work on it. You'll get good at it like we always do. I know you watch these things probably like I'm never going to get this, but we always do because that's how good we are. All right. So we'll work on tomorrow. Can't wait to see you then.